imagine 10th class. You wake up in the morning, your alarm didn't ring, your fan is off, your fridge is warm, no lights, no charging of your phone, even no internet on the router. What is so common among all these problems? Exactly what you're thinking is that's electricity. So, without electricity, our modern life has almost come to an halt. But have you ever wondered what exactly the electricity is? How does it travel through wires and reach to your home? What exactly happens? The bulb glows instantly when you turn on the switch. So this is what we are going to find out in the whole chapter. So hello 10th class. Today we are going to begin with a new chapter, that is electricity. This chapter is super interesting and this chapter is really important for those who are going to pursue science after their 10th grades, because this chapter extension they will be finding in their 12th standard as well. So let's start with the first topic. Today, as we begin this chapter, electricity, we are not just studying a simple physics topic. We are actually learning the secrets behind the life modern civilization. And by the end of this chapter, you will be able to explain why does the bulb glows and how, what kind of a connections are there that makes every appliance work individually, how your electricity bill is calculated. So we are going to learn all these concepts, why there are different switches for different electrical appliances, and why there are there by the fairy lights, the Diwali string of lights are turn on and off with a single switch. So it's the secret lies behind the connections. So are you going to light up your brains with the power of electricity? So we are starting with a new topic, the first topic of this chapter, that is the types of charges. So it is very important for all of us to understand that there are two types of charges, the positive charge and the negative charge. So when you're talking of a positive charge means the charges having lesser electrons. And when you're talking of a negative charge, that means it has more of electrons. So we have altogether two types of charges. जैसे हम chemistry में पढ़ते हैं cations और anions. Similarly, physics में भी जो charges होते हैं, that reflects the same. So negative charge has excess electrons and the positive charge has scarcity of electrons. So this is how we can understand this. Positive charge have always scarcity of electrons, whereas negative charge has always excess of electrons, children. Right? So you can imagine this as a tank full of water and the tank, the empty tank on the other side. So the tank full of water, or the tank or the side which is full of electrons, is known as negative side of the battery or the negative charges, and the positive means it is always having scarcity of electrons. Now we'll understand the behavior of charges. So the unlike charges always attract each other, means the positive charge always attract negative charge and the negative charge attracts the positive charge, vice versa. So when you talk about like charges means negative, negative, they always show repulsion. And when you are talking of positive, positive charge, right, positive and positive charge, they also shows the repulsion. अब ऐसा क्यों होता है that opposite charges attract each other and the like charges repel each other? अब आप समझेंगे, जो negative charge होता है, it is always having excess of electrons and the positive charge is always having scarcity of electrons. तो ये attraction क्यों हो रहा है? Because the negative charge can give the electrons to the positive charge and both will be happy. Right? जो excess होगा वो कम वाले को दे सकता है जिसके पास scarcity रहता है. But if you look for the like charges or the similar charges and then we show the repulsion over it. तो अगर हम repulsion की बात करें तो repulsion क्यों है बच्चा? They both have excess, so they don't need it, right? So it shows what? It shows repulsion. And in case of positive charge, अगर हम positive charge की बात करते हैं बच्चा, so positive charge both are having scarce of electrons, they are having lesser or fewer electrons, so both are not in a position to fulfill each other need. So in that case also they are absolutely going to show the repulsion. तो ये समझना बहुत जरूरी है कि unlike charges attract क्यों कर रहे हैं और like charges repel क्यों करते हैं. So जो unlike charges होते हैं वो एक चार्ज दूसरे चार्ज की नीड फुलफिल करता है. Negative charge is always having excess of electrons, whereas The positive charge is always having stars of electrons. So negative charge is always in a position to fulfill the need of positive charge because of excess of electrons. But when you are talking of the similar charges, positive, positive, negative, negative. Negative में तो दोनों ही fulfill हैं, तो why do they need that, right? Second, अगर हम पॉजिटिव पॉजिटिव की बात करते हैं, सो पॉजिटिव पॉजिटिव के केस में बोथ the charges are scarce, so both are not in a position to fulfill each other's need. Now we'll understand, बिकॉज इलेक्ट्रिसिटी को समझने के लिए चार्जेस को समझना बहुत जरूरी होता है. यू हैव अंडरस्टैंड द टू टाइप्स ऑफ चार्जेस. You have understood the behavior of the charges when they come together. Now you're going to understand the conservation of charge. So when we're talking of conservation of charge, the total charge cannot be, new charge cannot be created, nor it could be destroyed, right? So the charge remains same in an isolated system. So it only occurs the movement of charge from the excess electrons to the place where there is scarcity of electrons. So total electric charge in an isolated system is always remains the same, and charge cannot be created nor or destroyed, right? So आपको ये बात समझनी होगी कि जो चार्जेस होते हैं वो कंजर्व्ड रहते हैं. हमेशा फ्लो कहाँ से होगा? जैसे हम ऑस्मोसिस में पढ़ते हैं, डिफ्यूजन में पढ़ते हैं, सिमिलरली चार्जेस के साथ भी है. जहां एक्सेस चार्ज मतलब होता है इलेक्ट्रॉन्स, कितना इलेक्ट्रॉन फ्लो कर रहा है. चार्ज कब क्रिएट होगा? वेन एवर देयर इज फ्लो ऑफ इलेक्ट्रॉन्स, राइट चिल्ड्रन? अब इलेक्ट्रॉन्स कहां से कहां फ्लो करेंगे? इलेक्ट्रॉन्स विल फ्लो फ्रॉम वेयर दे आर एक्सेस टू वेयर दे आर स्कार्स, right children? So it is very important for us to understand कि हो क्या रहा है, क्यों हो रहा है, every why and how. Are you getting it? If you get it, so that remains there in your brain forever. So कंजर्वेशन ऑफ चार्ज टॉक्स अबाउट कि जो टोटल चार्ज रहता है एक आइसोलेटेड सिस्टम में, वो हमेशा कंजर्व रहता है, वो हमेशा सेम रहता है. सो आप न्यू चार्ज क्रिएट भी नहीं कर सकते हो, ना ही आप जो एग्जिस्टिंग चार्जर्स को डिस्ट्रॉय कर सकते हो. देयर इज ओनली द मूवमेंट फ्रॉम द एक्सेस टू द डेफिशिएंसी, राइट चिल्ड्रन? सो now moving ahead towards the quantization of the charges. Now what do we understand by quantization of charge? अगर मुझे quantization of charge समझना है, तो I need to understand that charges always exist in discrete packets. अब पैकेट्स में क्या होता है, इसको कैसे समझोगे? पैकेट्स में आपके पास कैंडीज आती हैं, पैकेट्स में आपके पास कोई भी चीज होती है जो होल में आती है. यू नेवर गेट अ हाफ or in fraction or a part of it. So charges always exist in discrete packets, right children? That means they are not continuous. So the minimum packet size is the size of 1 electron. So आपको चार्ज कैसे मिलेंगे? आपको चार्ज मिलेगा कि इसमें 1 इलेक्ट्रॉन चार्ज है, राइट? लेट मी चेंज इट. इसमें 1 इलेक्ट्रॉन चार्ज है, या फिर इस पैकेट में 2 इलेक्ट्रॉन्स हैं, या फिर इस पैकेट में 3 इलेक्ट्रॉन्स हैं, एंड सो ऑन, ऑलवेज एज अ होल नंबर. यू नेवर गेट इट एज द पैकेट इज हैविंग 1.5 इलेक्ट्रॉन्स or 2.5 electrons or 3.8 electrons. So आपको कभी भी ऐसा नहीं मिलेगा. You always get a charge as a whole number that is in discrete packets. So here we are going to understand that the charge Q represents charge. बच्चा Q represent क्या करता है? यहाँ पे Q क्या है? Q is a symbol for charge and the SI unit for charge is coulombs. ये आपको ध्यान रखना है. What is the SI unit of charge? That is coulomb, and we denote it with capital C. किससे denote करते हैं हम? Capital C. So here we have a formula. Q is equal to N into E. So N represents the discrete packets. कितने packets हैं? 1 electron है, 2 electron है, 3 है, 10 है, 20 है, 100 है और 1000 electrons है, right? And E represents the charge on 1 electron. E क्या represent करता है? The charge of 1 electron or proton. The charge is same. The difference is only with the positive and negative. So charge on 1 electron will be 1.6 into 10 raised to the power minus 19 coulombs, राइट. सो आपको जब भी फाइंड आउट करना है कि टोटल चार्ज कितना है, सो व्हाट आर यू गोइंग टू डू? द लॉजिक इज वेरी सिंपल. और इस टॉपिक के ऊपर आपका एनसीईआरटी में भी क्वेश्चन है चिल्ड्रन, सो प्लीज अंडरस्टैंड इट वाइजली. सो इलेक्ट्रिक चार्ज is equal to number of electrons into the charge on one electron, that is represented by small. Right, children? So that talks about the quantization of the charges. Charges are also countable. They exist as whole number. They never exist as a part or the fraction. Right? So let us move ahead. Let's solve one problem here. Right, children? So we have a question with us. Calculate the number of electrons constituting 1 coulomb of charge. What is it saying? Calculate the number of electrons. आपको क्या find out करना है? आपको number of electrons find out करना है. Means आपको n की value find out करनी है. Charge आपको कितना given है? 1 coulomb given है. Right? And charge on 1 electron you are provided with, that is 1.6 into 10 raised to the power minus 19 coulomb. And number of electrons is 1. So clearly this question I've written here, this question belongs to NCERT. So how you're going to do this question? You're going to use the formula Q is equal to N into E. So let's solve together. Right, what is given to us? Right, we are given a charge, means Q. Let me rub this. We are given a charge, that is Q. Q is equal to N into E. Right, children? So हमारे पास given क्या है? Q, which is equal to 1 coulomb, right? And the charge on 1 electron is given by E, which is 1.6 into 10 raised to the power minus 19 coulomb, right? And what we need to find out? We need to find out the number of electrons, right, children? So we have 1.6 into 10 raised to the power minus 19. We have to find out N, and the charge. Okay. All right. So we are provided with 1 coulomb of charge. We need to find out the number of electrons. And this is 1.6 into 10 raised to the power minus 19. So N is given by 1 upon 1.6 into 10 raised to the power minus 19. Right. So that will be 1 upon 1.6 into 10 raised to the power 19, children. Because whenever we have the negative power, we flip it and the power becomes positive. It changes its sign, right? So here you can also write this as, 10 upon 16 into 10 raised to the power 19. Right, children? Which is equal to 5 upon 8. Into 10 raised to the power 19. So you can also make it 50, and here you can write 10 raised to the power 18 upon, you have 8. So that is equal to 6.25. So which is 6.25 into 10 raised to the power 18 electrons. Right, children? So if you're taking 1 coulomb of charge, it is having 6.25 into 10 raised to the power 18 electrons. So this is how you can also count the number of electrons when the charge is given to you. Ab 2 coulombs mein find out karna hai, so multiply it with 2. 3 coulombs mein find out karna hai, so multiply with 3. So similarly, you can find out. So let's move ahead and to the next topic. It is very important for all of us to understand what are conductors and insulators. ये सब बच्चों को पता होता है, mostly बच्चों को ये बात पता होती है that conductors are those which allow the electric current to pass through it easily, whereas insulators does not allow the current to pass through it. But what makes the electric current to pass through it? Electric current is free electrons. अब current कहाँ flow कर सकता है? Where there is availability of free electrons. So let's talk about the conductors. What is there in the copper which is not there in the wood? So copper is having free electrons present into it, whereas wood does not have free electrons. That is why copper is put in the list of conductors, whereas wood, plastic, and rubbers are there in the list of insulators. सो अब कंडक्टर्स के पास क्या रहता है, फ्री इलेक्ट्रॉन्स रहते हैं, जिसकी वजह से वो इलेक्ट्रिसिटी कंडक्ट कर पाते हैं, वेयर एज इंसुलेटर्स डज नॉट हैव फ्री इलेक्ट्रॉन्स ड्यू टू विच दे आर नॉट एबल टू कंडक्ट द इलेक्ट्रिसिटी. How can you use conductors? We can use conductors by making wires and circuits. We can also use to insulators so that the electric current must not flow out. So we can cover the wires with a plastic and a rubber for a safety purpose. So insulators are equally important as though conductors, right? So conductors allow the electricity to flow, whereas insulators basically blocks the electricity, whereas insulators basically blocks the electricity. So clearly you have understood now that conductors allows the electric current to pass through it easily, whereas the insulators does not allow the electric current to pass through it. Free electrons are present with the conductors, whereas no free electrons is present with the insulator. When you're talking of examples, we have given you why certain materials are conductors and certain are insulators. Question आपको ऐसे भी आ सकता है, because some materials have free electrons which makes them conductor and some materials do not have free electrons which makes them insulators. So conductors helps in conduction of electric current, whereas insulator help us to protect from the excess current flowing through the circuit. So all the copper wires, all your connecting wires are having an insulating covering over it. Why is it so? So that no excess current flows throughout and to prevent anyone from electric shocks. Now we are going to start with the next topic, that is electric potential. अब बच्चा अगर हम electric potential की बात करते हैं तो इस टॉपिक को आप बहुत ध्यान से समझेंगे. There are two words. ठीक है, अब इसको समझने के लिए you must know potential energy. Potential energy क्या होता है? Anything which is kept at a height means water stored in a dam is having a potential energy. Similarly, the charge stored at some height, राइट से सपोज यहाँ पे हाइट पे बहुत सारा चार्ज स्टोर्ड है. सो इस चार्ज के पास क्या होगा? इट इज हैविंग पोटेंशियल एनर्जी. नाउ आई हैव टू डू सम वर्क टू मूव दैट चार्ज फ्रॉम वन प्लेस टू द अनदर प्लेस एंड दैट इज नोन एज इलेक्ट्रिक पोटेंशियल. उसको हम क्या बोलते हैं? इलेक्ट्रिक पोटेंशियल. सो मूवमेंट ऑफ द चार्जेस फ्रॉम वेयर इट इज इन एक्सेस टू वेयर इट इज लेस or reduced in number, that is known as children electric potential. So electric potential mein you do not know how much distance has been covered by the charge. So we usually say that electric potential is the work done in moving unit positive charge from infinity to that point, right? Electric potential क्या होता है बच्चा? It is the work done to move unit positive charge from infinity to that point in an electric field. अब जैसे ये चार्ज पार्टिकल है, ये किसी पॉइंट इंफिनिटी पर था और ये मूव करके किसी एक्स पॉइंट पर पहुंच गया है. सो यू डोंट नो हाउ मच डिस्टेंस इट हैज कवर्ड. सो इसीलिए हम इसको क्या बोलेंगे? इलेक्ट्रिक potential. The charge is kept at certain point and they're allowed to move the force which is required to move, the work done to move that charge from infinity to a particular point, that is known as electric potential. उसको हम क्या बोलते हैं बच्चा? इलेक्ट्रिक पोटेंशियल. इलेक्ट्रिक पोटेंशियल का सिंबल भी क्या होता है? V होता है. इलेक्ट्रिक पोटेंशियल की यूनिट भी क्या होती है? V वोल्ट होती है, राइट? And 1 volt is equal to 1 joule per 1 coulomb. So what does that mean? अब इसका क्या मतलब है? आप क्या डिफाइन कर रहे हो? अगर मुझे इलेक्ट्रिक पोटेंशियल बताना है, सो माय इलेक्ट्रिक पोटेंशियल जिसको मैं V से डिनोट करूंगी, that is equal to work done upon the charge, right? Work done upon the charge. राइट चिल्ड्रन, आप 1 कूलम चार्ज को मूव करने के लिए अगर 1 जूल ऑफ वर्क करते हो, दैट इज नोन एज इलेक्ट्रिक पोटेंशियल. बट इलेक्ट्रिक पोटेंशियल में मूवमेंट कहां से कहां होती है? मूवमेंट इज ऑलवेज infinity to any point, right? Let's say the point is x. सो दैट इज नोन एज इलेक्ट्रिक पोटेंशियल. अब फिजिक्स में हमें ध्यान रखना होता है, चिल्ड्रन यूजुअली लर्न द डेफिनेशन, वो इजी होता है, बट फिजिक्स में आपको एसआई यूनिट का भी डेफिनेशन आता है. सो इफ आई नीड टू डिफाइन माई 1 वोल्ट हियर, राइट, सो 1 वोल्ट कैसे डिफाइन करेंगे? इलेक्ट्रिक पोटेंशियल इज गिवन बाय वोल्ट, सो 1 वोल्ट इज इक्वल टू 1 जूल अपॉन 1 कूलम. सो आप कैसे बताओगे? इफ 1 जूल ऑफ वर्क इज डन to move 1 coulomb of charge, then we say that at that point the potential will be 1 volt. अगर 1 joule of work किया जा रहा है to move 1 coulomb of charge from infinity to that point, that is known as electric. Then the potential, electric potential will be 1 volt, right children? So electric potential में क्या रहता है? Electric potential में it will always be the movement of the charge from infinity to that point. और अगर मुझे 1 volt define करना है तो मैं कैसे define करूंगी? I'll take help of the formula. I'll put the SI unit of each and every physical quantity. So SI unit of electric potential is volt, SI unit of work done is joules, and SI unit of charge is coulombs. So आपको अगर 1 volt को डिफाइन करना है, आप विद रिस्पेक्ट टू वर्क डन एंड इलेक्ट्रिक चार्ज करेंगे. सो वर्क डन क्या होता है? व्हेन 1 joule of work is done to move 1 coulomb of charge from infinity to that point, then we say that at that point the potential is 1 volt. Is that clear, children? Now we are going to understand the electric potential. Electric potential, sorry, we have understood. Now we are going to understand potential difference. अब हम potential difference समझते हैं. अब potential difference क्या होता है? You know from where to where the charge is moving, right? Say suppose, let me explain you. Yes. So let's say I have 2 points, point A and point B. Right, children? The charges are present at point A, and I have to move these charges, that means the electrons, to point B. Then the work done to move those charges from terminal A to terminal B, that is known as potential difference. अब पोटेंशियल डिफरेंस में आपको पता होता है कि चार्ज कहां से कहां मूव कर रहा है, बट इलेक्ट्रिक पोटेंशियल में चार्ज इंफिनिटी पॉइंट से मूव कर आ रहा है तो हम इलेक्ट्रिक पोटेंशियल बोलेंगे. किसी एक पॉइंट पर हम क्या बोलेंगे? दैट मींस अगर मुझे ए पॉइंट का बताना है तो मैं बोलूंगी इलेक्ट्रिक पोटेंशियल एट पॉइंट ए. अगर मुझे बी पॉइंट का बताना है देन आई विल से इलेक्ट्रिक पोटेंशियल एट पॉइंट बी. Right, children? And if I need to tell, I have to look for the work done moving the unit positive charge from one point to another in an electric circuit. That will be the potential difference between the 2 points. And potential difference, right, children? Potential difference from A to B, right, is given by potential at B, final point, माइनस द पोटेंशियल एट पॉइंट ए. तो ये आप हमेशा ध्यान रखेंगे. सो हाउ विल वी डिफाइन चिल्ड्रन? Electric potential difference, work done in moving unit charge from one point to another in an electric circuit is known as potential difference. इसको हम क्या बोलते हैं? Potential difference. Now when you talk about the formula, it remains same, क्योंकि potential, electric potential बोलो या फिर potential difference बोलो, बात तो वही है. Charge move कर रहा है, the work done in moving a charge, that is known as potential difference. So that is work done upon क्वांटिटी ऑफ चार्ज मूव. सो इसका भी यूनिट क्या रहता है? इसका भी यूनिट आपका वोल्ट्स रहता है बच्चा. एंड 1 volt इज गिवन बाय 1 joule बाय 1 coulomb, right? For example, 10 joule of work to move 2 coulomb of charge will be the potential will be 5 volts. So potential कैसे देते हैं? Work done upon charge. So 10 upon 2 will give you 5 volts, right, children? Let us see its connections also. So how do we measure it? How do we connect it? That is what we are going to learn here. So children, potential difference को measure करने के लिए, electric potential को measure करने के लिए हमारे पास जो device होता है, we call that device voltmeter. क्या बोलते हैं हम उस device को? We call that device voltmeter. Right, children? So अगर आप इसको देखते हैं, voltmeter क्या होता है? आप इस device का नाम voltmeter है, तो इसीलिए हम commonly क्या बोलते हैं इसे? Voltage. क्या बोला जाता है? voltage, right children? The voltmeter is connected in parallel across the 2 points of the conductor. This is what we need to understand, children. So let us understand with this. So we have a conductor and it has its two ends, end A and end B. So one end of the voltmeter is connected to end A and the another end of the voltmeter is connected to end B. Such kind of connection is known as parallel connection when the same ends of the conductor and the voltmeter are joined together. So then we say that we connect the voltmeter in parallel. और सीरीज और पैरेलल कनेक्शन बच्चा आप आगे भी पढ़ेंगे. देन आई विल टेल यू इन डिटेल कि सीरीज और पैरेलल कनेक्शन का क्या रेलेवेंस होता है एंड हाउ डज इट वर्क. बट अभी के लिए आप ये समझेंगे कि व्हेन सेम एंड्स आर जॉइंड टुगेदर देन द कनेक्शन दैट काइंड ऑफ कनेक्शन is known as parallel connection. So where do we connect the voltmeter? We connect the voltmeter across the ends of the conductor, right? Across the ends of the conductor. And it always has the high resistance to avoid drawing excess of current, because voltmeter has to measure the electric potential, it has to measure the potential difference, or it has to measure commonly what do we say, इसको voltage measure करना होता है. So अगर हम इसमें current high resistance रखेंगे, so then it will allow almost no current or minimal current to pass through the circuit, and then current readings won't interrupt the voltmeters reading, right? The readings of the electric potential. तो ये हमारे लिए समझना बहुत जरूरी है. First, to measure the electrical potential or potential difference, we use a device which is known as voltmeter. How do we connect the device to the conductor? We always connect it parallelly, means we always join the same ends together, and we always keep the voltmeter at high resistance in order to minimize the flow of current through the circuit so that the current readings won't interrupt with the voltage readings. Right children? अब इसमें क्वेश्चन आता ही आता है, आपको कनेक्शंस पता होने चाहिए, अच्छे से पता होने चाहिए, because when you will be learning the circuits ahead in the chapter, you should be knowing. यहाँ से आपको पता होना चाहिए कि भाई वोल्ट मीटर है तो मैं उसको पैरेलल में कनेक्ट करने वाला हूँ. Right children? So now how much work is done in moving a charge of 2 coulomb from a point of 118 volt to a point of 128 volt? So the simply question is asking you about the work done to move a 2 coulomb of charge. So हम फटाफट से given लिखेंगे here, charge is 2 coulombs children, right? And the potential is, there is a potential difference, right? Potential difference is given by V2 minus V1. So as per question, your V2 is 128 and V1 is your 118. So potential difference or electric potential is your 10 volts. Right children? So V is your 10 volt. और आपसे क्या पूछा गया? आपसे पूछा गया work done. And we know that by formula V is equal to W upon Q. So we have 10 volt. We have to find out the work done. And the charge which is given to us is 2 coulombs. So work done is equal to 10 times 2, which makes it 20 joules. Very simple. So आपको जब भी पोटेंशियल एक पॉइंट से दूसरे पॉइंट पर गिवन होगा तो आप उसका पोटेंशियल डिफरेंस लेंगे to calculate the question and whatever has been asked in the question. Now children, we are starting with the next topic, that is our electric current. अब इलेक्ट्रिक करंट को समझने के लिए आप समझिए, you have a tank full of water and you open the lid of the tank. So when you have opened the lid of the tank, the water has started flowing. The water has started flowing, right children? Similarly, you have a battery which is full of electrons, right? उस बैटरी में क्या है? बहुत सारे electrons है. As soon as you turn on the battery and you connect the wires to it, the electrons start flowing through it, and that flow of electrons is known as electric current. उस electron flow को हम क्या बोलते हैं? Electric current. So amount of charge or the electrons flowing per unit time is given by electric current. Electric current को हम किससे denote करते हैं? We denote it with capital I. And what is the SI unit? SI unit of electric current is ampere. So इसीलिए यहाँ पे हमने क्या लिखा है? A. Right? Ampere को हम किससे denote करते हैं? Capital A. So I is equal to Q upon T. चार्ज फ्लोइंग थ्रू अ कंडक्टर पर यूनिट टाइम। तो अब फॉर्मूला खुद से, डेफिनेशन से ही बच्चा फॉर्मूला निकल जाता है। चार्ज फ्लोइंग थ्रू अ कंडक्टर पर यूनिट टाइम इज नोन एज इलेक्ट्रिक करंट। नाउ फ्लो ऑफ इलेक्ट्रिक चार्ज थ्रू अ कंडक्टर लाइक अ मेटल वायर is known as electric current. Now, what does the current, what allows the current to move from one terminal to the another terminal? That is the potential difference, right? अब potential difference का आप अब तक मतलब समझ चुके हैं. You are able to understand it. Means one point is having excess of electrons, and whereas the other point is having deficiency of electrons. So what will happen? It will always move from a point where there are excess electrons to a point where there is less or reduction in the number of electrons. So it is caused by potential difference between the 2 points. अगर potential difference नहीं होगा, will the current flow? The answer is absolutely not, because the charges always flows from the region of higher potential to the region of lower potential. Higher potential का क्या मतलब है? उसके पास ज्यादा charges हैं, और lower potential का क्या मतलब है? उसके पास कम charges हैं. तो चार्ज इलेक्ट्रॉन्स कहाँ से कहाँ फ्लो करेंगे? जहाँ पे ज्यादा होंगे वहां से उस रीजन में जहाँ पे इलेक्ट्रॉन्स कम होंगे. Right, children? So here we understand it clearly that for the electric current to flow, there must be a requirement. What is the condition which is required for the electric currents to flow? Simply potential difference. And we know that if there is no potential difference, for example, point A is having 10 volt and point B is also having 10 volt. So will the charges move from A to B? The answer is no, the charges will not flow. Say suppose point A will have 20 volt and point B will have 4 volt potential. So from where to where the current will flow? The current will flow from point A to point B. But you need to understand, say suppose the potential at point A is now 5 volt and the potential at B is now 20 volt. Now from where to where the current will flow? The current will flow from point B to point A, because it states that the charges always flow from the region, from higher potential region to the lower potential region. और charge आप electric current का formula क्या होता है बच्चा? Electric current is nothing but the charge flowing through a conductor per second. Electric current क्या होता है? The charge flowing through a conductor per second. Electric current को हम किससे denote करते हैं? We denote it with capital I. And what is the SI unit? SI unit of electric current is ampere, right? So इसको हम एम्पियर को हम किससे डिनोट करते हैं? दैट इज कैपिटल ए. तो आपको बहुत अच्छे से ध्यान रखना है दैट फॉर द चार्जेस टू फ्लो देयर मस्ट बी अ पोटेंशियल डिफरेंस एंड चार्जेस ऑलवेज फ्लो फ्रॉम हायर पोटेंशियल टू लोअर पोटेंशियल. नाउ लेट अस अंडरस्टैंड द कनेक्शन and the device which measures the electric current. Like इलेक्ट्रिक पोटेंशियल याद कैसे रखना है? इलेक्ट्रिक पोटेंशियल का ऐसा यूनिट होता है वोल्ट, तो उसके लिए डिवाइस हो गया वोल्ट मीटर, वोल्ट को मेजर करने के लिए वोल्ट मीटर. सिमिलरली इलेक्ट्रिक करंट का जो ऐसा यूनिट होता है वो एम्पियर होता है, तो एम्पियर को मेजर करने के लिए वी हैव अ डिवाइस एमीटर चिल्ड्रन. सो द डिवाइस वी यूज टू मेजर द करंट इज एमीटर्स एंड एमीटर्स आर कनेक्टेड इन सीरीज. अब सीरीज में पैरेलल मैंने आपको क्या बताया था कि उसमें सेम एंड्स कनेक्टेड होते हैं. डिवाइस का और कंडक्टर के जब सेम एंड्स कनेक्ट होंगे तो उसको हम पैरेलल कनेक्शन बोलेंगे. बट अगर डिवाइस और आपका व्हाट डू वी से device and your conductor different ends are connected together, that is known as series connection. उसको क्या बोलेंगे हम बच्चा? We call it series connection. जब आप एमीटर को कंडक्टर से कनेक्ट करते हैं तो आप किस कनेक्शन में करते हैं? सीरीज में. आप रेजिस्टेंस कैसा लेते हैं आप हमेशा? इट ऑलवेज हैज अ वेरी लो रेजिस्टेंस so that maximum amount of current can flow through it and the ammeter must give the accurate readings. Now there is one more measuring device which is used to measure the current and that device is known as galvanometer. उस डिवाइस को हम क्या बोलते हैं? We call that device galvanometer. एमीटर के लिए हम डिवाइस में हमेशा ए लगाते हैं, और गैल्वेनोमीटर के लिए हम डिवाइस में जब सिंबल बनाएंगे तो हम कैपिटल जी लगाएंगे हमेशा. अब व्हाट इज द डिफरेंस बिटवीन एमीटर एंड गैल्वेनोमीटर? एमीटर measures the current in ampere, whereas galvanometer measures the current in milliampere, where 1 milliampere is equal to 10 raised to the power minus 3 ampere. So that means whenever you need to measure or you need to check the presence of current, which device are you going to pick up? That is galvanometer. And whenever you need to measure the current, that too in amperes, which device are you going to pick up? You're going to pick up ammeter. Is this clear, children? So ammeters को हमेशा हम सीरीज में कनेक्ट करते हैं और गैल्वेनोमीटर्स को हमेशा हम सीरीज में ही कनेक्ट करेंगे. एमीटर्स हमारा मेजर करेगा करंट एम्पियर में, गैल्वेनोमीटर मेजर करेगा मिली एम्पियर में. एमीटर और गैल्वेनोमीटर दोनों का ही रेजिस्टेंस हमेशा बहुत लो रखा जाता है, so that the whole or the maximum amount of current which is present in the circuit can flow through it, and the two devices are able to measure give you the accurate readings of the current flowing through the circuit. तो आपको कनेक्शन अच्छे से पता होना चाहिए, आपको रेजिस्टेंस पता होना चाहिए. वोल्ट मीटर का कनेक्शन पैरेलल होता है, एमीटर का कनेक्शन सीरीज में होता है. वोल्ट मीटर में हम हाई रेजिस्टेंस रखते हैं, एमीटर में हम लो रेजिस्टेंस रखते हैं. ये छोटी छोटी सी बातें आपको आगे चल के चैप्टर में हेल्प करेंगी, एंड दीज ऑलवेज हेल्प यू टू सॉल्व दी questions or assertion reasons. Right, children? Now we are going to practice some questions in this class, क्योंकि physics एक ऐसा subject होता है जिसमें आप सीखते हैं और साथ साथ apply करना भी सीखते हैं. You're learning the concept as well as you're learning to apply that concept. So I have got couple of questions for you. Although questions video में हमेशा chapter के end में लाती हूँ. So the charge of 150 coulomb flows through a wire in 1 minute. What is the electric current flowing through it? Very simple MCQ है. आपसे given क्या है? आपको Q given है, that is 150 coulombs, right? आपको time given है, that is 1 minute, और आपको पता है कि हम per second करते हैं, so we convert this minute into seconds, which is equal to 60 seconds, right, children? Now what you have to calculate? You have to find out the electric current flowing. Very simple. We know that I is equal to Q upon T. But here time you have to take in seconds, not in minutes. तो आप हमेशा SI यूनिट पे काम करते हैं. SI यूनिट होती है करंट की एम्पियर, which is given by 1 coulomb. Right, per 1 second means when 1 coulomb of charge is flowing through a conductor in 1 second, then we say that 1 ampere of current is flowing through the conductor. So we have the charge which is 150 and we have the time which is 60, right, children? So this will be giving you 2.5 ampere. So the right option is 2.5 ampere. So this is how we can simply solve the questions. Be careful about the units. अब बच्चों से गलती कहाँ होती है? Question easy है, सब कुछ given है, बस put करना है. अब गलती कहाँ होगी? बच्चा 1 minute directly put कर सकता है, because अगर उसने ध्यान नहीं दिया कि जब भी आप question solve करते हो तो हर quantity as per SI unit के according put करनी चाहिए. Right. Now we have the next question with us. A current of 10 ampere flows through a conductor for 2 minutes. What is the amount of charge passed through the conductor? अब आपके पास करंट गिवन है I, which is equal to 10 ampere. आपके पास टाइम गिवन है, that is 2 minutes. So आपको कन्वर्ट कर देंगे 120 सेकेंड्स में, और आपसे पूछा गया है चार्ज. So I is equals to Q upon T and Q is equal to I into T. So which is simply 10 times 120. So which is 1200 coulomb. So option A is the right one. Very simple. Take care of the SI unit. Right? Now moving ahead, we have a current of 1 ampere is drawn by a filament of an electric bulb. नंबर ऑफ इलेक्ट्रॉन्स आपको फाइंड आउट करने हैं. तो नंबर ऑफ इलेक्ट्रॉन्स के लिए आपने एक ही फॉर्मूला लर्न किया है, दैट इज इक्वल्स टू Q is equal to N into E. Right, children? So Q stands for the charge, N stands for the number of electrons जो आपको find out करना है, and E stands on the charge on one electron. So आपके पास what is the you don't have Q, but you have I and you also have the time period. आपके पास करंट है 1 एम्पियर और आपके पास टाइम पीरियड है विच इज 16 सेकेंड्स चिल्ड्रन. तो आपको पता है कि Q क्या होता है, I इंटू टी. तो यहां से आप Q निकाल लेंगे विच इज 1 टाइम्स 16 विच विल गिव यू 16 कूलम्स. अब हम क्या करेंगे, N इज इक्वल टू Q अपॉन E हो जाएगा. सो Q क्या है आपका 16, E क्या है आपका 1.6 इंटू 10 रेज टू द पावर माइनस 19 कूलम. तो ये वैल्यू आपको हमेशा याद रखनी होती है, ऐसा जरूरी नहीं है कि आपको आ जाए, राइट. सो आप इसका डेसिमल हटा के ऊपर 10 कर देंगे, 16 विल कैंसिल 16, राइट. और जब 19 ऊपर जाएगा तो वो पावर जो होगी वो पॉजिटिव हो जाएगी. सो 10 रेज टू द पावर 19, लॉ ऑफ एक्सपोनेंट वी विल अप्लाई हियर. व्हेन bases are same, they are in multiplication, powers get added. So that will give you 10 raised to the power 20 electrons. Very simple. So that is 10 raised to the power 20 electrons. Got it, children? So this is how we can clearly do the questions we are having from this topic. We have covered 3 topics here. We have learned about the quantization of charge. We have learned about the electric potential and potential difference, and we have also learned about the electric current in this session. And in next session, I'm going to take the topic ahead. We will be learning about types of direction of electric current. One is your actual direction and conventional direction. Till then, prepare this topic, practice it.